So welcome to Yogi's lectures. So in this session we discuss about the electromagnetic fields. So in this series of lecture we can produce the various concepts of electromagnetic fields. So first of all we go for a introduction. So here first of all, what is electromagnetic field? So it is nothing but physical field produced by electrically charged objects, the combination of electric field and magnetic field. So electric field is produced by stationary charges and magnetic field is produced by moving charges, that is current. So here the electric fields are in stationary charges and magnetic fields are moving charges. So if we can say other words, the study of electric field and magnetic field together based on the state of source objects. So here we can see the diagram. So this is positive charges and this is the negative charges. First of all, we go discuss about the electric charges. So here the positive charges are moving away from the center, and here the negative charge ends in a inner side. So this is the two sides. So the electric flux lines going away from charge and electric flux lines ends at negative charge. So here the charges are entering in negative, so ends at a negative charge. Here the charges away from the positive charge. So this is the electric field. And so whenever we discuss about the magnetic field, we see this bar. So magna bar. So here this N, north pole and south pole. So here these lines are nothing but a magnetic flux lines. So these magnetic flux lines are always started from north pole to and ended at south pole. So this is the electromagnetic field. So once again, so the electromagnetic field is nothing but stationary charges, and magnetic field is produced by the moving charge. So here we can describe about the right hand thumb rule. So this is the right hand thumb rule. So this right hand implies this bar magnet. So here we can current in a upward direction and current distribution, that is upward direction, and hold to the direction of magnetic flux. These lines says that direction of magnetic flux. So here thumb is represent the direction of current in upward, and then this magnetic flux lines is holding hand. So this is the represent here the current in upward condition and surrounded by the magnetic line. So the right hand thumb rule says direction of thumb is a current direction, and holding fingers says direction of magnetic flux lines. So now we can discuss about the electromagnetic waves, that is nothing but EM waves. The combination of electric field and magnetic field is called electromagnetic waves. So always we can say that this is the representation of electromagnetic waves. So here we have two types of waves, one in a vertical and another one is the horizontal. So here these lines come for vertical lines, and these slanting waves are come for the horizontal lines. So this vertical lines is nothing but electric field, and this horizontal waves is nothing but the magnetic field. The electric field in vertical field and magnetic field in the horizontal field. So EM waves, electromagnetic field, is one of the fundamental force in nature. So all the energy transformation, that is the energy transformation means one form to another form. So for the example, we have described about the lightning. So similarly, Faraday, Ampere's, Henry and Oersted, Green, Maxwell's, Thomson's, and Hertz. So these are the similarities of the waves. So which is describe the EM waves. Why we should studying this subject? Why we want to study the EM waves? So EM waves is all around us. So wherever we go for a wireless communication, and then we can discuss about the EM waves. So we want to know the electromagnetic waves as electronic students. So and then working of all the devices such as on off switch in electric devices and electronic devices are or pressing keys are follows four Maxwell's equations. So these devices are using under the principles of electromagnetic waves. So and then we can now we go for a discussion about the units and constants. So in general, most important units are mentioned as a internationally accepted that units are set as SI units. So international system of units. The SI system is nothing but international system of units. So here these units are classified as two types: primary units and secondary units or derived units. So in primary units, so they come under the primary units: length, that is your meter, and mass, which is described the kilogram, and time, which describes the seconds, current, which describes the ampere, and temperature, which describes the kelvins, and luminous intensity, that units are candela, and substance, mole. And secondary units are derived units. So the secondary units are derived from the primary units. So first one is frequency. The unit is hertz, which is represented by 1 by S, and second unit is force, and then second unit is force and newtons, represented by newtons, kilogram into meter divided by second square, and power in represented by watts, V into A, and then electric charge is represented by coulomb, so seconds into ampere, and flux density Tesla, which is equal to kilogram into S square, kilogram divided by A into S square. So and some of the universal constant, this is velocity of light, which is represented by C, which is equal to 3 into 10 power 8 meter per seconds. Permittivity, which is represented by epsilon naught, which is equal to 8.854 into 10 power minus 12 F by M. And permeability, which is represented by mu naught, which is equal to 4 pi into 10 power minus 7 Henry per meter, and C is equal to 1 divided by square root of epsilon naught into mu naught. So up to this we discuss about the introduction about the electromagnetic fields. So next lectures we can discuss about the vector analysis. So thank you. So most of the viewers are viewed this lectures without any subscription. So you are requested to subscribe and then give a comments about this video, so then only we can produce the variety of videos as per your requirements. Thank you.